Hello everyone, myself Professor Amol Mishra, Assistant Professor of Department of Electrical Engineering of SND College of Engineering and Research Center. Today we are going to study on the topic protection against overvoltages due to switching and lightning surges, in which we are studying the protection against overvoltage due to lightning and switching. During operation, power system equipment such as generator, transformer, transmission lines, circuit breaker may subject to overvoltage. Overvoltage occurs due to lightning, opening of circuit breaker, and so on. The causes of overvoltage. There are two types of causes. First one is internal cause, and second one is external cause. In external causes, there are lightning surges or tree. Reason of external causes are lightning surges, tree falls on transmission lines, causes short circuit and three-phase short circuit, etc. The internal causes are insulation failure due to resonance or arching ground or switching surges. Types of overvoltages. There are three types of overvoltages: power frequency overvoltage, switching overvoltage, lightning overvoltage. Yep. We are seeing the first one, power frequency overvoltage. It does not have damaging effects like switching or lightning surges. It will be harmful if sustained for longer duration. It mainly due to it causes are ground faults, sudden load reaction, loose connection, etc. Then switching over voltage, also known as switching surge or over voltage transient. Sudden rise of voltage for a very short duration in power system network is known as a transient voltage for voltage surge. It is also due to switching process, that is opening and closing of circuit breaker. An electrical transient appears if there is a sudden change in state of energy in power system network. This sudden change is due to closing a switch, opening a switch, occurrence of fault in system, or closing of circuit breaker, opening of circuit breaker, etc. To control the switching over voltage, resistor is inserted between the contacts while switching off the circuit. Lightning over voltage. Lightning is an electric discharge between cloud and earth or between clouds. It is basically a huge spark. A large number of discharge occurs between or within clouds than to earth, and enough of them terminate on the earth, causing serious hazards. Following actions of the high lightning stroke generate transients. First one is a direct stroke to phase conductor. Second one is a stroke to earth very close to line. A surge diverter. What is surge? Surge disturbances on a power waveform that can damage or destroy equipment within any home, commercial building, or manufacturing facility. Surges are measured in microseconds. A surge diverter. A surge diverter is a piece of equipment that diverts excess voltage to earth, thus protecting sensitive electrical and electronic equipment. The surge diverter is normally installed in a main switchboard. Requirement of a surge diverter. It should not pass any current at normal and abnormal power frequency voltage. It should break down as quickly as possible after the abnormal high frequency voltage arrives. It should not only protect the equipment for which it is used, but should discharge current without damaging itself. It should interrupt power frequency, follow current after the surge is discharged to ground. There are types of surge diverters. First one is a rod gap surge diverter. Second one is a protector tube or expulsion type surge diverter. Third one is a valve type surge diverter. We are seeing the first one is a rod gap. It is rod gap type surge diverter. It is a very simple type of diverter and consists of two 1.5 centimeter rods. One rod is connected to the line circuit and the other rod is connected to earth. The distance between gap and insulator must not be less than one third of the gap length so that the arc may not reach the insulator and damage it. The rod gap should be so set at that it breaks down to a voltage not less than 30% below the voltage withstand level of the equipment to be protected. Here, image shown the road gap type surge diverter, in which the transformer bushings are shown. The road gap is shown, rod connected to the line is shown, and the transformer tank is shown. The string of insulator for an overhead line on the bushing of transformer has frequently a rod gap across it. Under normal operating conditions, the gap remains non-conducting. On the occurrence of a high voltage surge on the line, the gap sparks over and the surge current is connected to earth. In this way, excess charge on the line due to the surge is harmlessly conducted to earth. Limitations. After the surge is over, the arc in the gap is maintained by the normal supply voltage, leading to short circuit on the system. The rods may melt or get damaged due to excessive heat produced by the arc. The climatic condition, example rain, humidity, temperature, etc., affect the performance of road gap arrestor. The polarity of the surge also affects the performance of the arrestor. Second one is the expulsion type surge diverter. This type of arrestor is also called as protector tube and it is commonly used on system operating at voltages up to 33 kV. It is essentially consists of a rod gap in series with a second gap enclosed within the fiber tube. The gap is in the fiber tube is formed by two electrodes. The upper electrode is connected to rod gap and the lower electrode to the earth. The expulsion type lightning arrestor are shown in the figure. Here is the arc chamber, fiber tube, electrode, and the line which are connected, and the series external gap between the lines and vent for the gases are shown. The series gap is set to arc over a specified voltage lower than the withstand voltage of the equipment to be protected. The follow-on current is confined to the space inside the relatively small fiber tube. Part of the tube material vaporizes and the high pressure gases so formed are expelled through the vent at the lower end of the tube, causing the power flow in arc to be extinguished. The device therefore has the desired self-clearing property. The advantages are they are not very expensive, they can be easily installed, and they are improved form of broad gap arrestor as they block the flow of power frequency follow currents. Limitations of expulsion type broad gap arrestor. An expulsion type arrestor can perform only limited number of operations as during each operation some of the fiber material is used up. This type of arrestor cannot be mounted on enclosed equipment due to discharge of gases during operation. Due to the poor volt ampere characteristic of the arrestor, it is not suitable for protection of expensive equipment. Third one is the volt type arrestor. The volt type arrestors incorporate non-linear resistor and are extensively used on system operating at high voltages. It consists of two assemblies. First one is a series spark caps and second one is a non-linear resistor disc. The non-linear elements are connected in series with the spark gaps. Both the assemblies are accommodated in tight porcelain container. The spark gap is a multiple assembly consisting of a number of identical spark gaps in series. Each gap consists of two electrodes with fixed gap spacing. The spacing of the series gaps is such that it will withstand the normal circuit voltage. An overvoltage will cause the gap to break down, causing the surge current to ground via the non-linear resistor. The non-linear resistor discs are made up of inorganic compounds such as ferrite or metrosol. These discs are connected in series. The non-linear resistors have the property of offering a high resistance to current flow when normal system voltage is applied, but a low resistance to the flow of high surge currents. The figure shows the valve type arrestor, in which the porcelain housing and multi-gap assembly are shown, the silicon carbide blocks are shown, the spark gaps and grading are shown, and set of non-line are shown. When the surge is over, the non-linear resistor assume high resistance to stop the flow of current. Under normal condition, the normal system voltage is insufficient or insufficient to cause the breakdown of air gap assembly. On the occurrence of an overvoltage, the breakdown of the series spark gap takes place and the surge current is connected to earth via the non-linear resistances. Since the magnitude of surge current is very large, the non-linear elements will offer a very low resistance to the passage of surge. The surge will rapidly go to earth instead of being sent back over the line. The advantages of fault type arrestor are they provide very effective protection against surges. They operate very rapidly, taking less than a second. The impulse ratio is practically unity. The limitations of fault type arrestor are they may fail to check the surge of a very steep wave front reaching the terminal apparatus. This calls for additional steps to check steep fronted waves. Their performance is adversely affected by the entry of moisture into the enclosure. This necessitates effective sealing of the enclosure at all times. Thank you.